Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P050A, indicates a cold start idle air control system performance problem in the Honda Fit from 2015 to 2020. This code is related to the Powertrain Control Module, PCM, which manages various engine functions, including idle air control. When the PCM detects that the idle air control system is not functioning within the expected parameters, it triggers this DTC. The cold start process is critical as it controls the air-fuel mixture and engine operations during low-temperature conditions. Proper functioning ensures the engine starts smoothly and runs efficiently. Addressing this issue promptly is essential to maintain engine performance and minimize emissions. The DTC P050A confirms a cold start idle air control system performance issue, affecting the Honda Fit's engine functionality. The primary component involved is the idle air control system, which regulates the air entering the engine during cold starts to optimize performance and emissions. This system is critical for maintaining a stable idle speed when the engine is cold, ensuring it runs smoothly until it reaches optimal operating temperature. The malfunction can lead to rough idling, stalling, or even difficulty starting the vehicle. It's often located near the throttle body, allowing it to directly control the air mixture entering the engine. If unexplained performance problems occur, further investigation of the idle air control system and associated sensors is warranted. Several factors can contribute to the DTC P050A. A poor connection or blockage at the intake air duct can obstruct airflow, disrupting the performance of the idle air control system. Compromised connections may lead to unintended air leaks, affecting how the engine functions under cold start conditions. Another potential cause is a clogged air cleaner housing. If debris obstructs airflow, it can severely impact engine performance by preventing the air-fuel mixture from achieving the desired ratios. Additionally, if the air cleaner element is dirty, it can further limit airflow, exacerbating idle stability issues. Each of these components plays a vital role in engine management, so addressing these causes is fundamental in resolving the DTC. Symptoms associated with DTC P050A may manifest as a rough engine idle, particularly noticeable when the engine is cold. Drivers may experience difficulty starting the vehicle, as the engine struggles to achieve the necessary idle speed due to incorrect air-fuel mixtures. Increased emissions can also indicate that the engine isn't operating efficiently, as improper air control can lead to a richer mixture and higher pollutant output. Observing these symptoms promptly is integral in diagnosing the root of the problem. Early recognition can facilitate timely repairs, helping preserve engine health and uphold environmental standards by minimizing tailpipe emissions. The first step in troubleshooting DTC P050A involves turning the vehicle ignition to the on mode without starting the engine. This ensures that all electronic systems are powered. Next, it's essential to check for pending or confirmed DTCs using the Honda Diagnostic System, HDS. This diagnostic tool allows you to retrieve fault codes effectively. Pay special attention to whether there are any other error codes present besides P050A. If there are additional DTCs, they may indicate other underlying issues requiring immediate attention. Conversely, if P050A is the only code present, proceed to the next troubleshooting step to investigate potential causes specific to the idle air control performance. In the second troubleshooting step for DTC P050A, a visual inspection of the intake air duct is crucial. Checking for loose connections or physical blockages can reveal issues affecting airflow to the engine. It's important to ensure the duct is securely attached and free from debris that could hinder performance. Any signs of wear, damage, or disconnects should be addressed immediately to prevent airflow restrictions. If the air duct is in good condition, you can confirm it's not the source of the trouble. However, if you find any irregularities, reconnect or repair the air duct accordingly before proceeding to the next step in the troubleshooting process. The third troubleshooting step mandates a thorough visual check of the air cleaner housing. Similar to the previous step, identifying any poor connections or blockages is critical for confirming system integrity. Blocked air cleaner housing can limit airflow, vital for engine optimization, particularly during cold starts. Ensure all connections are tight and that there's no visible debris obstructing airflow paths. If the housing is secure and free of obstruction, mark this as resolved. If any issues are discovered during this check, replacing the air cleaner housing may be necessary, which can significantly impact the idle air control system's performance. In the fourth step of resolving DTC P050, inspecting the air cleaner element is essential. The filter must be clear and free from dirt and debris to allow optimal airflow. Accumulation of contaminants can restrict airflow, leading to poor engine performance. If the air cleaner element appears dirty, then replacing it with a new one will enhance the operation of the idle air control system. A clean air filter is fundamental for ensuring that the engine receives the correct amount of air required for efficient combustion, especially relevant during cold starts. If the air cleaner element is clean, then proceed with further diagnostics. The fifth step in troubleshooting DTC P050A requires that the engine cools down until the engine coolant temperature ECT sensor reads 122 degrees Fahrenheit, 50 degrees Celsius or less. This temperature condition is necessary for accurate testing of the idle air control system under cold start conditions. Following the cooling period, clear the DTC using the HDS, effectively resetting the system. Once cleared, start the engine and allow it to idle for at least 10 seconds. Throughout this period, monitor the onboard diagnostic status for DTC P050A. If the system indicates a failure, it suggests that the problems persist, justifying further investigation. Conversely, a pass indicates the issue may be intermittent or resolved temporarily. In the sixth step of troubleshooting DTC P050A, selecting the Electronic Throttle Control System (ETCS) test using the HDS is required. This test assesses the performance of the throttle actuator control valve. This valve is crucial in regulating engine airflow and maintaining optimal idle speed. If the test identifies that the throttle actuator control is abnormal, immediate replacement of the throttle body is necessary. A malfunctioning throttle body can lead to numerous performance issues, including stalling or erratic idling. Conversely, if the throttle is functioning properly, we can proceed to the next step, focusing on the mass airflow MAF sensor's performance. The seventh troubleshooting step necessitates starting the engine and maintaining an engine speed of 3,000 RPM without any load for accurate performance checks, especially until the radiator fan activates. Once the engine stabilizes, check the readings of the mass airflow MAF sensor using the HDS to assess its performance. The optimal threshold for MAF sensor readings varies between 3.8 to 5.4 grams per second for manual transmission and 3.9 to 5.5 grams per second for continuously variable transmission (CVT) models. If the readings do not align with these thresholds, it indicates that the sensor is faulty and requires replacement. Ensuring proper function of the MAF sensor is key, as it directly affects the air-fuel mixture, critical for engine performance. The last troubleshooting step involves assessing the intake air temperature, IAT, sensor performance. First, cool the engine to ambient temperature before turning the vehicle to the on mode to observe the IAT sensor's value through the HDS data list. It's essential to compare the noted IAT value with the ambient temperature. If the IAT differs by 5.4 degrees Fahrenheit or 3 degrees Celsius or more from the ambient temperature, it suggests the IAT sensor is defective and needs replacement. If the temperature readings are consistent, this indicates that the IAT sensor is functioning normally. In such cases, inspect the throttle body for dirt, carbon buildup, or potential damage, as these factors can also affect performance. After completing all the necessary repairs for DTC P050A, performing a test drive is crucial to ensure that the vehicle operates normally. Monitoring the engine's performance under different driving conditions will confirm whether the repairs effectively resolve the issues. Observe particularly for any signs of rough idling or starting difficulties that may indicate the persistence of the problem. It is also helpful to utilize the HDS to check for any reappearance of the DTC after repairs. Confirming that the issue has been adequately addressed ensures successful troubleshooting and promotes confidence in the vehicle's operational integrity moving forward. Preventive maintenance plays a vital role in avoiding issues related to DTC P050A in the future. Regularly replacing the air filter is crucial to ensure optimal airflow to the engine. A clean filter helps maintain engine performance and efficiency. Periodically inspecting the intake ducts for any signs of wear or blockages can also preempt airflow problems before they exacerbate into more significant issues. Moreover, keeping the throttle body clean of dirt and carbon buildup is imperative for its optimal performance. Creating a maintenance schedule that includes these checks and replacements can significantly reduce the risk of similar DTC occurrences, promoting longer engine life and enhanced performance for the Honda Fit. In conclusion, understanding DTC P050A and its associated symptoms is crucial for ensuring the Honda Fit operates efficiently. Following a structured, stepwise troubleshooting approach can help mechanics pinpoint and address issues related to the cold start idle air control system effectively. It is essential to recognize the importance of component checks, such as the intake air duct, air cleaner housing, and MAF sensor. Each plays a significant role in the engine's performance. Implementing preventive measures and routine maintenance helps mitigate future occurrences of this DTC. Ultimately, staying proactive and informed can ensure that the vehicle remains in optimal condition, reducing downtime and repair costs. Please like and subscribe to the channel. See you next time.